Alright guys, let's look at this question. A lot of times when I see this kind of question, right, as a student, it used to throw me off because I think that, wow, so complicated, so many things to look at. Actually, it is fairly straightforward. If you look at one cell by itself, right, let's look at the first one on the left. So you have your copper 2 plus and your X2 plus. We're comparing the reactivity of these two metals. Obviously, there's a potential difference because it shows up here, 0.5. Okay, what this means is that at the anode, right, where you have oxidation of this metal X and reduction of copper. So copper is the less reactive one, right? This is the more reactive. And this copper is the less reactive, okay, because it gets reduced, okay. Metal X is more reactive than copper, okay. So this is the first one. The second one, because copper is at the same position and metal Y is at the same position as metal X, and this voltage, right, is even higher. So what this means is that X is more reactive than copper. No, sorry, not X. Thing. Okay, Y is also more reactive than copper, and at the same time, Y is also more reactive, most likely, than your X because the voltage is higher. Okay, so now we have Y greater than X, which is greater than copper. Then now we switch position, right? Copper is like more reactive than Z because copper gets oxidized here and you still get a positive voltage. Okay, so copper is more reactive than metal Z. That's about it. Okay, so you're just comparing one by one by one. The voltage telling you, all right, how much more reactive is the metal compared to the previous metal, the one that is at the cathode. Okay, so we are looking for Y is the most reactive, then weakest to the strongest. So weakest D, then copper, then X, then Y. Okay, so our answer here is C.